Welcome to Zero to CCNP, the pathway to CCNP certification. And as we know that there are two certifications we do in this one. So the very first thing that we should understand is that in CCNP or the Cisco track, we start with CCNA, which is the associate certificate or entry exam. But that is not a prerequisite to become a CCNP certified. I mean, having knowledge of CCNA is always great, but certification is not a requirement. So if you are certified, that's great, CCNA certified. If you are not, you can still go for the CCNP certification directly. Now, when it comes to the professional level, you will see that Cisco has restructured everything. Before, it used to be three different exams, route, switch, and T-shoot. And when you finish these three exams, then you used to get the CCNP badge, so CCNP certified uh, status, I would say. And also, after that, if you are planning to go in future for CCIE, earlier there used to be a dedicated CCIE qualification exam, which you had to pay extra to prepare and then to take the exam. That was also a multiple choice question exam. And that qual exam, once you pass, you will be able to, you had the chance to book the lab, basically. You would be able to book the lab only if you had passed that exam. But now they restructured it, and it's actually for better, because first of all, to become CCNP certified, now you need to pass only two exams, not three exams. And these two exams are divided into two parts. One is the core exam, and one is the concentration exam. So the core exam is always going to be one core exam depending on which particular topic you are going for or stream you are going for, like enterprise, which is the name for routing and switching, security, service provider, collaboration, or data center. So for every particular stream, you have a core exam and then one of the concentration exam, because for concentration exam, you have many different options, like which particular topic you want to specialize in, you want to go deeper, you can actually go for that concentration exam. Now, since we are talking about CCNP enterprise infrastructure, which is routing and switching, so we are talking about the ENCORE exam. ENCORE is the core exam for enterprise network, and then we can actually go for one of the concentration exam. So concentration exam, you have options to go for routing and services, which is called NRC, and that's what this class is about. But there are other options also, like designing networks or implementing wireless network, software defined networking, or even automation and programming. That also is one of the concentration exam that you can go for. So once you pass the core, which is the ENCORE, and one of the concentration, like in this case, we are going with NRC, you become CCNP certified. So you need these two exams to become CCNP certified. Now, when you want to go for CCIE, the good news is that since you already passed the ENCORE exam, after you complete CCNP, let's say you take the ENCORE exam, you pass the ENCORE exam, that also works as a qualification exam for the CCIE lab. So you don't need to take another separate qualification exam that you had to do before. But now you pass the ENCORE exam, and now you can already book the CCIE lab exam as well. So that's actually a very, very useful thing. And the ENCORE exam for enterprise works for two different CCIE streams. You can go for CCIE enterprise infrastructure, which is basically routing and switching, or you can go for CCIE enterprise wireless lab exam. So wireless CCIE wireless also you can book if you have passed the ENCORE exam. That's why you will see that in ENCORE you also have some basic knowledge of wireless. So in case if you want to go in that direction, you will have proper idea what you are getting into, right? Or if you want to go for routing and switching enterprise infrastructure, of course, that's what we concentrate more in that part. So this particular one, as I told you, is going to be about NRC, and NRC is about routing and services. So you don't have any switching questions in this. Switching actually is covered into ENCORE, but we will go into in-depth concept of routing, including EIGRP, OSPF, BGP, and some of the services, specialized configuration like policy-based routing or IPSLA. These configurations will there be as well, right? So this program is a complete program. Like if you join a CCNP from Karotul, you get the training for both core and the concentration exam. So the concentration exam is NRC, and it started with version 1.0, and currently 1.1 version is going on. Slight differences were there, and we have incorporated those differences. So when we are going to cover NRC, we are going to cover the latest syllabus for NRC that we have. So speaking of NRC syllabus that covers the exam objective of 300-410, it's here. So you can actually download it from Cisco website also, the official version 1.1 syllabus. And we are going to cover all the topics that we see here, right? So for example, layer 3 technologies, where it starts with the concepts of administrative distance and troubleshooting administrative distance in all routing protocols. For example, if you have the same route from multiple routing protocols, which one is going to be preferred? What is the order of operation of checking that? So we always go for the longest matching prefix first, and then we check the AD, administrative distance. If that's also same, then we check the routing protocol metric. So that's the order of checking. So we are going to check that as well. We'll understand the concept of route map for any routing protocol, whether it is for attributes like in BGP, we will go in deep about route map configuration for path attributes manipulation, but it can also be used in redistribution for tagging purposes or for route filtering if you want to remove some routes from the routing table when the routes are coming in, or when you want to filter them out before sending routes to your neighbor. So route map is a very, very important concept, and it's crucial to understand how does it work, what is the order of operation in that, and how can we use it with the different routing protocols. Troubleshooting loop prevention mechanism, that is something also we'll see. Mostly in redistribution, the loops can happen. Or if you're using a distance vector routing protocol, they are always prone to loops. For example, EIGRP or BGP or RIP, routing information protocol, they're always prone to looping. So how can we actually use some features like split horizon or route poisoning to prevent these kind of loops? Another thing we are going to cover is redistribution. Very, very important topic. Redistribution is actually introducing routes from one routing protocol to another routing protocol. And we will see why do we need this and what is the use case. And of course, then we will see how exactly we can configure it. So basically, any technology that we are going to cover, we will always go through these three important questions. What is the technology we are talking about? Why do we need it? I mean, what exact problem it is solving? And then, of course, the biggest question, how to configure it and how to troubleshoot it. That is something we are going to see. Also, we are going to cover summarization in routing protocols, manual and automatic summarization. How can we control it? And how can we plan our networks so that the networks are properly summarized and we save the space into our routing tables and also save the bandwidth when we are sending the updates from one router to another router. Policy-based routing is a very interesting concept. So in traditional routing, when a packet arrives, we always check the destination network, destination IP into the packet, and we try to find the matching entry into the routing table. So traditional routing is destination-based routing, where you are going, that decides what will be the next hop, right? What will be the next router. But policy-based routing can actually go beyond the destination IP address, and it can check many things into an IP header. You can decide the next stop based on where are you coming from, where are you going, which application you are coming from, source port number, which application you are going to, destination port number. Even you can check which protocol you are using, and also some other things like what ICMP code you are using into the packet header, and any quality of service marking if there is any. So we can actually check many things to decide what will be the next stop. So that's called the policy based routing. Very interesting. We will have a lab for this as well. Apart from the detailed understanding, again, going to go through with three questions. What is PBR? Why do we need this? What exact problem is it solving? And of course, how to configure it. Another very important topic is VRF Lite. So VRF is a concept of using dedicated virtual routing tables for customers. So this is mostly used on the service provider side, but VRF Lite can be used in the enterprise networks as well to compartmentalize your networks using the same infrastructure. So you can have the same set of routers and switches, but two completely separate routing tables, maybe running two different businesses, but using the same infrastructure. So VRF Lite is also a very interesting concept. We will learn that. BFD, bidirectional forwarding detection, which is actually to find out the failed neighbors or failure into the network as quickly as possible. It is actually sub-second detection. You can go into milliseconds, and within few milliseconds, you can find out if the link is down or if the neighbor is down. And accordingly, you can force the routing protocol to break the neighborship way before the normal hold down time or dead interval can actually find it out. And then we will move to the routing protocols. So we are going to cover two IGPs in detail, EIGRP and OSPF. So EIGRP, or Enhanced Interior Gateway Routing Protocol, it is the Cisco proprietary routing protocol. Although back in 2013, Cisco had revealed its source code. So anybody who want to implement EIGRP type of protocol, they can actually copy it. So you can consider it like kind of open standard now. But the version that Cisco is implementing is still the proprietary version into their routers. It's a very efficient protocol. It's a distance vector routing protocol, but it has some trick up its sleeves to make it better than normal distance vector routing protocol, for example, RIP. So unlike RIP, it is highly advanced, and we are going to learn a lot of information about EIGRP. We are going to go through very structured manner. Like first of all, the neighborship comes up, then the routes are exchanged, and then the best route election happens, and then after that, the maintenance of EIGRP. That if there is a fault, if there is a network failure, how does EIGRP cope with that? How does EIGRP respond to that? We are going to learn all these things, right? We are going to learn some important concepts of neighbor relationship authentication, and for loop free path selection, we are going to understand many different things like reported distance, visible successor or successor, all these things, visibility condition, stuck inactive, stub router, load balancing, and what is the EIGRP metric? How does it actually calculate the best path? So all these things we are going to learn in this course. Then comes the OSPF. So OSPF is the link state routing protocol, and it's a highly efficient protocol, very useful, and it has a little bit of learning curve, but it's a very interesting protocol. So we will have more than one labs actually for OSPF to go through and understand how exactly this protocol works. So in our class, the structure of the class would be, we will start with the theory. Again, we'll go through the three important questions: what is the technology, why do we need it, and how to configure it. I'll show you some examples, and after that we will switch to lab. So within the live Zoom session, I will actually solve the lab step by step, configuring it on EVNG, so that you can see how exactly it needs to be done. And then the same lab I'm going to send you along with the solution file. So just to give you an example, one of the OSPF lab we will do will have a topology like this, where we have multiple areas. As you can see, area 0 in the middle, then area 1 on the left hand side, area 2 is on the right hand side. And then I'll send you the instructions for this as well. Like just to take an example, like OSPF, one of the OSPF lab, you can see we have more than one labs. So there will be instructions what needs to be done, and uh, we actually have some certain problem statements here, right? For example, create a loopback with this IP on router 7 and advertise this in OSPF, and make sure that the area 2 routers do not get this loopback of router 7, and also change the network type. So once you read this, I'll do this in the live Zoom session. I'll configure this step by step in front of the live audience here. But then, of course, when you are doing it, you can always scroll further to the next page, and you will see the solution as well. What exactly do you need to configure to get the solution done for that purpose, right? So we're going to cover OSPF as well. All the important topics of OSPF: areas, virtual link, and area type: backbone, normal, transit, stub, not so stubby area, totally stubby area, all these things. Different types of networks: point to point, multi-point, broadcast, non-broadcast. What difference are there between them? And again, why do we need so many areas? And then how to configure it. So what, why, and how, we are always going to structurize our concepts in that manner. Then comes the EGP, the Exterior Gateway Protocol, named BGP, Border Gateway Protocol. So we are going to understand the Border Gateway Protocol, IBGP and EBGP, Unicast and VRF Lite. And we are going to understand neighbor relationship and authentication, path preference. So path attributes, how we can use path attributes to basically manipulate a particular route preference for BGP, and how do we do the traffic engineering? How do we affect the traffic that is moving from point A to point B? Route reflection and little bit of configuration also, although it's not part of CCNP, it's part of CCI, but I'll explain a little bit of configuration concept as well. And then we will learn the policies, inbound, outbound filtering, and path manipulation. Then comes the VPN technologies. We are going to understand MPLS operations. What exactly is MPLS and how does it work? So you can see that in the syllabus, you have some keywords here. In some technologies, they use the keyword describe, and in some technologies they use the keyword configure. So if you see a keyword configure, you need to know configuration as well. If they say just describe, you need to know just the logic and the concept of that technology. For example, for MPLS, they are saying describe MPLS. So you will not see a lab in the exam about MPLS. That is guaranteed. But when they say configure DMVPN, it may or may not have a lab in the exam where you need to click on the router and configure something or troubleshoot something. So we are going to learn these VPN technologies, multi-protocol label switching, and the DMVPN, which is called the dynamic multi-point VPN. So very, very interesting. We will have labs for anything that needs configuration. And then comes some miscellaneous topics like security. We're going to go through the ACL, Unicast reverse path forwarding, and AAA, which is called the authentication, authorization, and accounting. We will also understand control plane policing so that we can control who can access our device with the management protocols like Telnet, Secure Shell, HTTP, and all these things, right? And also what security features do we have in IP version 6? So although in this particular syllabus, they don't have IPv6 or dedicated IPv6 topic, but I'm going to cover IPv6 from start again, because you can see IPv6 will be used many times in EIGRP, in OSPF, in BGP, and then again we will have IPv6 here with the IPv6 first of security features. So we need to know IPv6 logic and concept. So we are going to cover that as well, right? And then comes the infrastructure services, like how do you access the router using console and the terminal, virtual terminal lines, telnet or secure shell? How do you access router using HTTP or HTTPS? How do you copy files with the secure copy SCP or using FTP and TFTP? So these are basically infrastructural services that we are going to understand. And then there are some other services like SNMP, syslog, IPSLA, IP version 4 and IP version 6 DSCP, NetFlow, and some of the basic idea about how the management is done, right? So that actually completes our syllabus, and that's what we are going to cover. So we will have a lot of labs wherever we can do the labs. Like if it's a configurational thing, we will do the lab. If it is just describing or the logic, then we will not do the lab for that. Like for example, MPLS, we will understand the concept in detail, but there will be no accompanying lab for that, right? As far as the topology is concerned, I have sent you already the OVA for 0 to CCNP, and let me show you what it will look like once you open it. So once you boot the OVA and you get an IP address, you will open that IP here, and the topology that we will be using is this topology. For all the practicals, we will use the same topology, so you can concentrate on the technology instead of designing, right? So we will be using 9 routers, as you can see, and these 9 routers will be used in different capacity. Like in some labs we will use all 9 of them. In some labs we might use only few of them, not all of them, right? So it depends on the topology. And IP addressing is also pretty straightforward. As you can see, we take any 2 routers, let's say router 1 and 2. So the first octet of the address is 12, because router 1 and 2, so 12. Between router 2 and 4 it is 24. Between routers 1 and 6 it is 16. Router 6 and 7 it is 67. So first octet is always the combined number of both routers. And then we have 0.0, second and third octet. And last octet would be .1 or .2, depending on the router number. Lower router number will be .1, higher router number will be .2. For example, between router 3 and 4 or router 2 and 3, 23.0.0, router 2 will be .1, router 3 will be .2. So 23.0.0.1, 23.0.0.2. And everywhere we are using the subnet mask of class C/24, as you can see. Apart from these addresses, the loopback IP address is also pre-configured. So every router has a loopback. You can see here at the right hand side top corner, x.x.x.x plus 32, where x is the router number. So for router 2, the loopback address will be 2.2.2.2. For router 5, it will be 5.5.5.5 and so on, right? So why I'm telling you this is because since we want to concentrate on the higher technologies like routing protocols, VPN technologies, and security configuration, infrastructure configuration. So we don't want to configure IP addressing every single time. That will take a lot of time, right? Instead, in this OVA, you will see that devices already have the IP addresses configured, and not only just the interface IP, but the loopback is also pre-configured. So you can directly start configuring the routing protocols, right? Also, whenever you are done with your configuration, you can save the configuration using copy, run, start, or write memory command inside the router. And then when next time you start the router again, it will resume the configuration from that point onwards. So if you are doing a lab, you are halfway through the lab and you want to shut down the devices, you want to restart again tomorrow, you can do that after saving the configuration, and you will get the configuration right from that point. You will not have to do it from the beginning. But once you are done with the lab, and you want to start the new lab, so you want to go back to the base configuration, just the IP addressing, you can actually go on the left hand side, more actions, and you can do a wipe all nodes. Remember, when you do wipe all nodes, all the configuration that you did, routing protocol, security, whatever, it will be gone, and the routers will have only the IP addresses configured, the interface IP addresses and the loopback IP address, right? Physical IP addresses, physical interface IP addresses, and the loopback interface IP address. That will be the only thing configured. So that's the basic idea, and this is the lab that we are going to cover. And of course, later you can join Encore, or if you already join Encore, you will see that it will have a separate topology, separate OVA, and separate syllabus that we will cover in the Encore Encore class. So as I mentioned, there will be one core exam and one elective exam. And the core exam also works as a CCIE qualification exam. So once you pass the core exam and core, you will be able to book the CCIE lab as well. Although you do get 3 years, so you don't need to hurry anything. You can do it whenever you are ready for CCIE or when you want to move to the CCIE. But if you want to become CCNP certified, you need to pass both exams, right? And NCORE is 350-401, and NRC is 300-410. So these are the exam codes when you want to take it in the Pearson VUE Center. And in our classes, we have separate OVS for both, so that you can concentrate completely on one topic at a time, and it doesn't affect the second one at all, right? And what will be the course structure for our 0 to CCNP? So this structure is actually 2 times a week, basically one for NRC and one for NCORE, if both are going on simultaneously. But if it is only NRC, then it will be 1 time a week, and it is going to be 2 hours per session. Although I always say this, that it's a topic driven course, not a time driven course. That means sometimes we might be done before 2 hours, sometimes it may take more than 2 hours if the topic is more detailed. So we are going to finish the topic no matter how much time it takes, right? And the live Zoom session with me, I will be explaining concepts and showing the lab configuration both. And roughly what happens is that it will be like 1 hour instructor-led topic discussion and 1 hour the lab on the same topic. Although again, this is not time driven. Sometimes the topic will be finished early and lab will take more time. Sometimes the theory will take more time and lab will not take more time. Sometimes both will take more time, going beyond 2 hours, as I was mentioning. So it's not time driven, but it's just a rough idea that this is how the course is structured. So we are going to make sure in this course that we do in-depth theory, because what happens is that whenever you think about troubleshooting, Troubleshooting completely depends on the in-depth knowledge of the fundamentals. For example, if OSPF neighborship is not coming up, if you know exactly what goes into an OSPF hello message when you start configuring it, you will be able to start troubleshooting there. So there are some things which must be same, like the network must be same between two routers, area ID must be same, timers must match, authentication if any configured, that also must match. So all these things you can check, and there are few things which must not match, like router IDs must be unique. So they should not be same. There should not be a conflict of router ID. IP address should not be same. Network should be same, but you cannot configure same IP both sides, right? So these are the things we can check. Uh, Type of area must also match. Like if one side is configured as a normal area, other side is sub area, the neighborship doesn't come up. So you see, when you have to troubleshoot, it depends on your core knowledge of the technology. That's why we give utmost importance to the in-depth theory, and we always structurize it in this way. What is the technology? Why do we need this? What problem is it solving? And then how to configure it. And then, of course, it is followed by multiple practical labs. So you will have a plenty of practical experience as well. Uh, for these labs, I am going to do the labs in the live Zoom session, and the same PDF I will be sending you after the class along with the solution file. And the reason I sent solution file as well is because it's not a test, right? So you have to have a mindset of learning when you are into the Zoom class or Zoom session, but you also need to have mindset of learning when you are doing the lab during the week, because it's not a test. So you don't need to remember everything from the Zoom session. And when I send you the PDF, you have to configure it without uh, looking at anything or from your memory. That's not the case. That's not the objective. The objective is to solidify the understanding and to learn it more when it comes to configuration. So feel free to look at the solution file as much as you want, because you are still learning when you are doing the configuration on your own, right? That's why it is a completely hands-on approach, and we use the EVNG based topologies with multiple routers and switches, which actually gives you an edge, as you can do it anytime and you can use as many routers as you want. You don't need to depend on the physical routers and switches. And the cherry on top, of course, is that you get lifetime access. So lifetime access means to the recordings. Now, any topic that you want to refresh your memory, you can always go to the portal 02it.com or karotul.mykazabi.com, and there you will be able to log in with your credentials, and you will get access to your class recordings. And it might be a recording of a previous class of NRC, but the topics will be same, and you will be able to refresh or revision anytime you like. And it's a lifetime access. So the good news is that in future, if Cisco adds few more topics or remove some things from CCNP and we update our recordings accordingly, you will get access to the latest information at that time as well, right? So that's what actually makes this course unique. So the core strength of this course is that it is actually perfect choice to advance in your networking acumen and career, because it based on the live Zoom sessions, and practical labs are provided with that. Q&A sessions to clear any doubts. So of course, this is one of the very, very important things. So many times when you do study on your own, or if you're just going through the books and you get stuck somewhere, you don't understand something, you don't have anyone else to ask. So you have to go to the forums or ask someone on the internet, some website, and then hopefully they give you the right answer. And that's not their priority anyway. So you might have to wait. So it actually just hinders your progress. But in our case, we have live Zoom sessions every week, so you can ask your questions. Even if it is not the live session, we have a Facebook group where you can ask questions and people can answer there, and I will also be answering there. So you always have some support. Anytime you have any question, you don't need to look outside. You get everything in this complete package. Of course, detailed solution files for practical labs are also sent along with the troubleshooting tips, and lifetime access to the session recording, right? And the tools that we use, as I mentioned earlier, is EVNG on VMware, and topologies are already set in EVNG. Labs files will be sent every week for the next week, and solution files will be sent along with the lab file, as I mentioned already, right? So during the off days in a week, you are encouraged to do the labs again, and of course, feel free to contact me in case of any question. There are two ways to contact me. Don't use email because that is not monitored. Instead, you can ask the question on the Facebook group, or if you're watching the recording on our website, you will see that below every recording there is a comment section where you can ask your question, and that also directly comes to me, and I will be answering you as soon as possible, right? So the EVNG that we use, uh, it has the topologies already pre-built in it, as you saw earlier when we were checking the OVA, right? So OVA file is already sent to you. You already imported it. If you have any issue with that, you can let me know. Recommended RAM for this CCNP course would be 8 gig, but I would say if you have 16 gig, that will be better. And make sure that the network interface or network adapter is set to NAT so that you can get an IP address and can use it for your purpose, right? So finally, a little bit about myself. My name is Arpit Pandit. I have two CCIs. One is in routing and switching, and one is in service provider. So back in the days when it used to be called routing and switching, now it is called enterprise infrastructure. And I have more than 16 years of training experience, and out of which last 10 to 12 years I have been training CCI mostly. Uh, Also extensive practical experience as well as a consultant. So I actually provide consultancy to various organizations, mostly service providers. And although it sounds like a cliche, but training is my passion. So for me and Christian, we feel very happy when we can actually help people to achieve their goals, and when they actually get clarity into a particular certification path or any technology. So that actually makes us very happy. So that's it from my side. So today was just the introduction. I wanted to explain you what we are going to start covering. So from next week onward, we are going to start the topics. So we'll start with EIGRP first, the routing protocol EIGRP, and the basics of routing protocol will be covered as well.